All right, guys. So we've been talking about this notion of limits, okay, this week. I'm not sure, I'm doing this on Monday. I'm not sure how much of this we've gotten through this week yet. But it is possible for a limit not to exist. Because remember, basically what we're asking here, or what we're looking for here when you're talking about a limit, is as we approach a specific number along the x-axis, what are the y values going to? Okay, so if you look at something like this, we worked with these rational functions last year. Okay, we know that this guy right here has a vertical asymptote, okay, at x equals -4. Okay, so notice as we are approaching from the right side, as we get closer and closer to -4, notice these y values go to positive infinity. Okay, that's what they're approaching. Okay, and as we approach -4 from the left, notice this graph is going down, okay, to negative infinity. Okay, so what happens here at a vertical asymptote is there's no way to calculate the y values. Okay, so if that's what we're looking for when we're talking about limits, what are the y values, there's no way to do it. Okay, so this guy right here, okay, we would say the limit doesn't exist, does not exist, DNE, okay, or we could say the limit is either going to positive or negative infinity, like this. Okay, in this case, okay, with a vertical asymptote. Okay, so as far as I'm concerned, those two answers basically mean the same thing. Okay, whether you say a limit doesn't exist because you have a vertical asymptote, or you say the limit is going to either positive infinity or negative infinity, they mean the same thing to me with this situation. And the reason being is that, you know, this notion of infinity, you can't really put a numerical value on it. It's undefined, okay, in our number system. Okay, we can't say, well, you know, what is infinity? So whether you say the limit doesn't exist or you say the limit exists at infinity means the same thing. So you just got to pay attention to who's in the front of the classroom. You might have somebody in college that'll say, you know, you have to say one or the other. Okay, so just be careful with who's in front of the classroom and what they're expecting out of you. Okay, but it is possible for us to have a non-existent limit. Okay, now another situation where this happens is this notion of one-sided versus two-sided limits, okay? And so when you're talking about a one-sided limit, that means we're approaching from one direction. So if you have a right-hand limit, that means what's going on with the y values as we approach from the right, okay? What are the y values going to? And then if you have a left-hand limit, we're talking about, okay, what are the y values approaching as we approach the number from the left? Okay, and we denote that by using this plus or minus, but we put it after the number. So if you see the plus sign after C, that means we're approaching C from the right. And if you see the minus sign after that C, it means we're approaching from the left. Okay, and one of the coolest functions to look at to demonstrate this notion, okay, is this greatest integer function. Okay, I don't think we teach this anymore in high school. I'll be honest with you, I haven't seen it in quite some time. I know they taught it in high school when I was in high school. I remember seeing it, but I don't remember, you know, I didn't remember much about it until I started using it here in calculus. Okay, it's a really strange looking function. Okay, so the greatest integer function, sometimes they represent it using this little like double bracket here, or they just write INTX, greatest integer function, okay, and it's defined very strangely, okay. What's the greatest integer or largest integer that's less than or equal to a number? Okay, that's how it's defined. So it's kind of strange, but it's cool to take a look at. So if we pull this guy up a little bit and we take a look at, well, what's going on here, okay, with this function, okay? And I'm going to start at the origin and work to the right, okay, and then start at the origin and work to the left, and you'll see what it looks like and some problems that we have. Okay, so if we start at 0 and we say, okay, what's the largest integer that is less than or equal to 0? What's the largest integer less than or equal to 0? Well, that'd be 0. okay? So it's right there. Okay, now we're working with numbers in between 0 and 1, so they're all proper fractions, so like 1/2, 1/4, 7/8, whatever. Okay, so you can just kind of take one of them and you say, okay, suppose I'm working at 1/2, and I say, what's the largest integer less than or equal to 1/2? Well, that'd be 0, okay? So all of these numbers have a y value of 0, okay? And then you get to 1, okay? And you say, okay, what's the largest integer that's less than or equal to 1? And you say, well, that's 1. Okay, so it bumps up like this. You say, well, what's going on down here? Well, you just have an open circle because the y value bumps up to 1. Okay, now we're in between 1 and 2. Okay, so like 1/2, 1 3/4, 1 4/5, whatever. Okay, but all improper fractions in between 1 and 2. So let's suppose we take 1/2. And you say, okay, what's the largest integer that's less than or equal to 1/2? Would be 1. Okay, so those guys all bump up here. All your y values are right here. And then you get to 2. And you say, okay, what's the largest integer less than or equal to 2? Well, that'd be 2. So it bumps up again. And you say, well, what's going on down here? I got an open circle. Okay, and so you say, okay, well, what about between 2 and 3? So you have like, again, 2 1/4, 2 7/8, 2 9/10, whatever. Okay, so you take anything in here, I'll just take 2.5. And I say, okay, what is the largest number that's less than or equal, or I'm sorry, what's the largest integer that's less than or equal to 2.5? Well, that'd be 2. Okay, so everything is shaded in here. And then we get to 3. And you say, okay, well, what's the largest integer that's less than or equal to 3? Well, that'd be 3. And again, it bumps up again. So you can see you have this pattern where it just keeps bumping up every time you get to an integer. Okay, it just keeps bumping up. Okay, like that. And the same thing happens down here. Okay, it just keeps replicating itself. Okay, and in this case, obviously, if we're working backwards, it's bumping down. Okay, but it keeps doing the same thing. Okay, all the way across. And so you have this very strange looking function. Okay, and it poses some problems. Okay, when you're talking about left-hand limits and right-hand limits. Like for instance, if we look at 1 right here. Okay, if we look at the limit as x approaches 1 from the left. Okay, so as we're approaching 1 from the left, notice that all the y values are at 0. Okay, but if we look at the limit as x approaches 1 from the right, okay, so if we're approaching 1 from the right, notice that all your y values are up here at 1. Okay, and you see how we have a left-hand limit that is one number and a right-hand limit that's another number, and so we got a problem here. Okay, so we say there's no limit because the one-sided limits are different. Okay, or we could say, the limit is DNE. Okay, whatever you want, however you want to get it across. Okay, and that happens at every single integer. Okay, for instance, take 4. And you say, okay, as we approach 4 from the right, okay, what's the limit? Well, all the y values are up here at 4. And you say, okay, well, what if we approach 4 from the left? All the y values are up here at 3. So you have a right-sided limit that gives you 4, and you have a left-sided limit that gives you 3. So once again, those are two different numbers. Okay, so right there, okay, we would say no limit. Okay, or the limit doesn't exist. And it's a really cool function to look at when you're talking about one-sided limits and two-sided limits. Okay, so very cool. Okay, and so we can take a look at this, and I'm not going to do every single one of these, and we'll take a look. There's some of these guys that work out just fine, and other guys we got some issues here. Okay, so if I remember right, these top 3 all work out. Everything's good. Okay, so we take this. Notice it doesn't say from the right or the left. Okay, so we have to assume that's a two-sided limit. So we'll look at, you know, what's going on with the y values as we come to the right and come from the left, and hopefully we get the same thing. Okay, so this first guy, I have the limit as x approaches 0. Okay, 2 times. Well, what's going on with f? So let's take a look at f as we approach 0. Okay, so as we approach 0 from the right, notice that all my y values are up here at 2. And if we approach 0 from the left, notice again all my y values are up here at 2. Okay, so the right-handed limit and the left-hand limit are both 2, so we're in good shape. Okay, plus 3 times, okay, g of x. What's going on with g of x as we approach 0? Okay, so if you look over here, as we get closer and closer to 0 from the right, notice all our y values are approaching 0. And as we get closer and closer to 0 from the left, all my y values are approaching 0. Okay, so that goes to 0. So notice we're going to get 2 times 2 squared, which is 4, plus 3 times 0, so we just get 8. Okay, so no big deal. So the first one was pretty easy. Let's take a look at this guy. Okay, now this one is a little bit different. Limit as x approaches -3. Well, you take a look here, notice you have g of x and fx, but then you have this x squared. So as x is approaching -3, x squared is approaching -3 squared. Okay, so we just get -3 squared. And then you look at g of x. Okay, we're approaching -3. Notice the negative sign is to the left of 3, so we mean -3. So let's see, we have -1, we have -2, we have -3. So what's going on as we approach -3 from both the right and the left? What's going on with our y values? Well, notice no matter which side we approach from, notice our y values are up here at 1. Okay, so the limit would be approaching 1. Okay, and then down here we have approaching -3 on f of x. So let's see, we have -1, -2, -3. So we've got this point right here. It looks like it's at -3, -1, like that. Okay, so as we are approaching -3 from both the right and the left, notice that your y values are going to -1. Okay, so it looks like we're just going to get 9 times 1 over -1, which gives us -9. Okay, now this guy we have function composition. Okay, all right, so let's see what goes on here. This I think is a typo, so let's not look at that guy. Okay, let's come down here. Let's take a look at these guys, because these guys pose some problems down here. Okay, this is another typo right there. Okay, all right, so let's see. What's going on here? Okay, so we're approaching -1, okay, and notice the negative sign comes before it, so we got to worry about approaching from the right and the left. Okay, so we have 5 minus, okay, let's see, as x approaches -1, x squared becomes -1 squared, and then we would have 3 plus, what's going on with f? Okay, right here, f of x, what's going on with that guy? Okay, as we approach -1 on f. Okay, so as we approach -1 from the right, notice that all your y values are up here at 2. But as we approach -1 for the left, notice that your y values are down here at 1. So this is like the greatest integer function. Notice how things hop up. So our right-hand limit is 2, our left-hand limit is 1. They're different, so we don't have a limit, okay? This is no limit. Okay, so if part of this function doesn't have a limit, the entire thing has no limit as well. Okay, and so we got a problem here. Okay, you got an issue. Okay, whether you want to say no limit or DNE, okay, same thing. Okay, so we got some issues. So some of these are okay, and obviously there's at least one that is a mess. Now, if you take a look here, notice this is approaching 1 from the right. I'm sorry, from the left. The minus comes after, so it'd be 1 from the left. Okay, so we got 2. Let's see what goes on. What's happening with f as we approach 1 from the left? Okay, so as we approach 1 from the left, notice all your y values up here, okay, are at 2, okay? Let's go. And then we have what's going on with g of x as we approach 1 from the left. Okay, so here is our 1 right here, and we're approaching from the left, so we're coming in this way. Notice your y values are going down to -1. Okay, so that would be -1. Okay, so we would get 4 over 1, which just gives us 4. Okay, now you say, well, wait a minute. When you're over here at f, we got a problem at 1 because things are hopping up and down. But notice it's only a one-sided limit. So I'm not worried about what's going on as we approach 1 from the right. I'm only talking about what happens as we approach 1 from the left. So does the limit exist? Not a two-sided limit, it certainly doesn't. Okay, but you do have a one-sided limit, so we can actually calculate what's going on here with this problem. Okay, that'll wrap it up for the first video.